Dear student, in the last period we learned find inverse of matrix and by elementary row transformation and column transformation. Today we learn the new method of finding inverse, and that method is inverse of matrix by adjoint method. And what is the adjoint method? This method is easy. Very easily we can find the inverse of matrix. Here, for finding inverse by adjoint method, we need or must know some terminology about adjoint method. Then what we learn first? Now listen here. The inverse of matrix by adjoint method. For this, we must know minor of matrix. Then we must know cofactor of matrix. Then we must know adjoint of matrix. And finding all these three, lastly we can find inverse of matrix. Now how to find? Let's first learn and then we solve one example. Then what is the minor of matrix? Let first. What is the minor of matrix? Minor of matrix, we consider here a matrix of order 3 by 3. A matrix A. Then minor are particularly for the elements. Means we minor the matrix. Here, listen here. For this element 1. For this element 1, this matrix element 1 in the first row and first column, therefore eliminate first row and first column. Means if we eliminate first row and first column, this determinant remains. Means this is the minor, therefore this is equal to 1, 2, 2, 4. And if we solve this determinant, that is 4 minus 4 equal to 0. Means minor of the first element 1 is 0. Now choose any other element. If we consider this one, this element. Yeah, this element is A11. Means first row, first column. If we consider this element, that is this element is row 2 and column also 2, means A22, it is 1. And what is the minor? This is in second column and second row. Eliminate both. What remains? Second row and second column eliminated. There 1, 3, 1, 4. 1, 3, 1, 4. And that is equal to 4 minus 3 equal to 1. This is the minor of A22. Now, consider this element. Here, what is this element? A third row, second column. Third row, second column. Third row, second column. Eliminate third row, second column. Third row, second column. Here, what remains here for this element? 1, 3 minus 1, 2. 1, 3 minus 1, 2. If we solve 2 plus 3 and equal to 5, this is the minor. In this way, we can find minor of all 9 elements. This is a minor of respective elements. In this way, we find the minor. Now, cofactor element. Then what are the cofactor element? For cofactor element, there is one coefficient to the respective elements. Now, how to find the coefficient? Means if we multiply by coefficient, we find their coefficient. We multiply to the minor by coefficient, then it is a cofactor. Now listen, how to find cofactor of the elements. Let the first This one is A11 equal to coefficient here -1 to the power addition of row and column in which the element included. Here 1 1 means 1 plus 1, and the minor we already learned. What is the minor? Minor of this one is 1 2 1 2 2 4. That is equal to -1 to the power 2 means -1 square. It is 1. Therefore 1. It is 1 2 2 4, and that is equal to 4 minus 4 0 in this way. Means -1 to the power number of row and column in which the element included. Consider second. If we consider this element, what is this element? Second row, third column. Second row, third column. Therefore, its coefficient is -1 to the power addition of 3 and 2, and that is 5. Addition of row, number of row and number of column. And its minor for this minor, eliminate second row and third column, that is 1 2 1 2 1 2 1 2. -1 to the power 5 is minus, and if we solve it, that is 2 minus 2, but it is 0. In this way we find the cofactor. Now listen, in finding cofactors we multiply by coefficient, and coefficient is -1 the power number of rows plus the number of column. Means if we consider this matrix, then for this element have a power, this element have a power 3, this element have a power 3, this element have a power 5, and this element have a power 5, and remaining element is this element. Here 1 2 3 4, this 4 element have a power odd numbers, and -1 to the power odd number means -1, and when power is even, -1 to the power even is even. Therefore no change in the sign. When power is odd, then change in the sign. Means for these 4 elements only changes the sign. And if we look the shape of this, if we join this 4 element, what is the shape of this 4 element when joining after them by a line? It is a diamond shape. It is a diamond shape. Therefore we said that it is a diamond element. This diamond element on the diamond, and when their power is odd number, sign changes. Means only this sign of this 4 element changes after multiplying coefficient. When we find the cofactor, only this 4 element sign for this 4 element changes, and remaining elements have the same sign. In this way we find the cofactors. Now what is the adjoint of matrix? Now adjoint of matrix, and here we find minor first. Here we find minor first, and suppose this is minor Mij, we find minor, then we multiply by coefficient, that is a cofactor element. If this is a minor, Then cofactor is minus 1 to the power m plus n mij, and this is minor, this is coefficient. In the minor, only determinant of order 2 by 2. In the cofactor, here coefficient. And now what is the adjoint? What is the adjoint? Adjoint of matrix is the transpose of cofactor matrix. That is, adjoint is written in this way. Adjoint is written in this way. Adjoint of A. If we take its transpose, what is meant by transpose of matrix? Convert it row into column and column into row. That is the transpose of matrix. Means minus 1 to the power m plus n m I j transpose. When we take transpose of cofactor of matrix, it is an adjoint matrix. Here all our these ideas cleared in one example. When we solved one example, we find first minor, cofactor, and then adjoint. How to find adjoint? By taking transpose. By taking transpose of the cofactor of matrix. And now inverse. Now inverse. That is A inverse equal to divide the adjoint matrix by magnitude of a matrix. Means in this way. This is the inverse of matrix. Here A inverse is equal to adjoint of A, means adjoint matrix divided by the value or magnitude of the matrix. Means when we find any value or magnitude of the matrix, divide it by the cofactor or adjoint of matrix divided by magnitudes, means divide every element of adjoint matrix by magnitude of matrix, and in this way we can find the inverse of matrix by adjoint method. All our ideas cleared in one example. Now let the example. Now let example find the inverse of matrix by adjoint. We discuss all the steps in finding inverse of matrix by adjoint method. Now let's start the example. In one example, we can easily understand how to find inverse by adjoint method. Now let example. Now example of in this example, find minor first, cofactor, adjoint, and then inverse. A cofactor, find cofactor of all elements. Cofactor of 1, this element here minus 1 to the power 1 plus 1, first row, first column, and this is the first cofactor of first element. Now consider this element 2, minus 1 to the power first row, second column. Its minor is 1527. Minus 1 to the power 3 means minus negative sign, diamond element. 7 minus 10, 7 minus 10, minus 3 minus minus, it becomes 3. Then this element 3 minus 1 to the power first row third column, then its minor is 1 1 2 4 1 1 2 4, and this is 1 to the power 4 means 1, 4 minus 2 2, then this element 1 minus 1 to the power second row first column 2 plus 1, its minor is 1 5 4 2 3 4 7 2 3 4 7, minus 1 to the power 3 means here minus sign, and 14 minus 12 is 14 minus 12 is, that is 2, this is 2, 14 minus 12 it is 2. Now this element 1 minus 1 to the power is minus 1 to the power 2 plus 2, minor is 1 3 2 7, that is equal to it plus 7 minus 6 1. Now this 5 minus 1 to the power 5 second row third column, that is 5, and its minor is 1 2 2 4, it is 4 minus 4 0. Now this 2 cofactor of this 2, 3 plus 1 minus 1 to the power 3 plus 1, and its minor is 2 3 1 5, 3 1 5, here plus, here 10 minus 3 7. Now this 4 minus 1 to the power, yeah, third row second column 3 plus 2, and its minor is 1 3 1 5, that is minus, because of odd power 5 minus 3, and that is 2, and last 7, that is minus 1 to the power 3 plus 3, and its minor is 1 2 1 1 1 2 1, that is plus, and here 1 minus 2, therefore it is a minus 1, this is minus 1. In this way we find the cofactors. Now these are the cofactors of all elements. Now how to write the cofactor matrix? Now consider these cofactors. The cofactor of matrix minus 30, 3, 2, minus 2, 1, 0, 7, minus 2, minus 1. In this way we find this is a cofactor of matrix, and if we take its transpose, then it is an adjoint matrix. Now adjoint of A, this adjoint of this matrix. This is a column, convert into row. Minus 13, minus 2, 7. Here, second column, 3, 1, minus 2. 3, 1, minus 2. Third, 2, 0, minus 1. And this is an adjoint of matrix. Now we find inverse. Then how to find inverse? Find the value of this matrix and divide all terms, all elements by the magnitude of matrix. Now let magnitude of A is this matrix. If we solve this matrix by converting it into determinant, we get its answer is minus 1. We directly take this value. And now inverse of matrix, A inverse is equal to, what is the steps? Adjoint of matrix A divided by magnitude of A. That is A inverse is equal to adjoint, 1 upon minus 1, this magnitude of A. And adjoint of matrix means this matrix. Minus 30, minus 2, 7, 3, 1, minus 2, 2, 0, minus 1. And multiply all elements by this minus 1. Then A inverse is equal to 13, 2, minus 7, minus 3, minus 1, 2, minus 2, 0, 1. And this is the inverse of matrix by adjoint method. In this way, we find the inverse of matrix by adjoint method. For this, the necessary terms are minor, cofactor, adjoint, and their inverse. And in this way, very easily we can find the inverse of matrix by adjoint method. The next part in next period. Okay.